Hi everybody. We're going to start chapter 10, and 10.1 is called Rationalizing the Denominator. And what we're going to be able to do at the end of the lesson is simplify a radical expression when the radical in the denominator is not a perfect square. What we have to rely on is what we learned in chapter 6 when we simplified square roots. So if we look at question number 1, we have negative square root of 175. So we'll look at 175 and we want to determine what is the largest perfect square that divides evenly into 175. And it's 25. So I'm going to split this into the negative root of 25 times the root of 7. And I pick those numbers because 25 times 7 is 175. Then you do the root that you know is a perfect square, so that would be 25. So the square root of 25 is 5, so I'm going to have negative 5 root 7, and that is the answer to that first question. For number 2, we have root of 48, and if I look at that, I have to find the biggest perfect square that goes into 48, and it is going to be 16. So I'm going to split this into root of 16 times the root of 3. Again, 16 times 3 is 48. You do the square root, that's a perfect square, and I'm going to get 4. So the answer to this one is positive 4 root 3. Go ahead and pause the video right now and do question number 3 on your own just to refresh your memory. Okay, and there's the answer. Hopefully you got it, negative 12 root 2. All right, the second part we did in 6 is when we had fractions, we realized that you're not allowed to have a fraction in a square root. So what we did is we split them. So we did the square root into the square root of 50 over the square root of 144. And then we have to simplify. So the first thing I look at is the top one here. Square root of 50, can that one be simplified? And it can, because 25 is a factor of 50, so I have to make this square root of 25 times the square root of 2 over square root of 144. And then you simplify all the roots that you can. So the top here, 25, the root of that is 5, so this will be 5 root 2. And at the bottom here, 144 is 12, and that is the correct answer. Looking at 5, again, we want to split it, so it's going to be the negative square root of 20 over the square root of 81. And we look at 20 and see, does a perfect square go into that? And it does, square root of 4. So we're going to make this the negative root of 4 times the root of 5 over root of 81. And then we will simplify what we can. So the square root of 4 is 2, so it'll be negative 2 root 5 over square root of 81, which is 9, and that is the answer. Go ahead and pause the video and do number 6. And there's the answer. Hopefully you got 3 root 6 over 7. The third thing we did in chapter 6 was we did it when it was in the context of a problem and we had to simplify roots before we could simplify fractions. So we're looking at this problem, 8 minus the root of 112 over 4. The first thing that we wanted to look at here was how do we simplify that root of 112? And again, you have to kind of rely on what we did earlier. And the largest square root that goes into 112 is 16. So when I do this problem, it'll be 8 minus root 16, and it's 16 times 7, so root 7. And all of that would be over 4. And then you simplify the roots that you can. So the root of 16 is 4, so we'll go 8 minus 4 root 7 over 4. And then the last thing that we did when we had a fraction is we wanted to simplify. Remember, you can only simplify if something goes into all of the parts. So when I look at that, 4 goes into both parts at the top. So if I divide them both by 4, I would get 2 minus 1 root 7. And the denominator would be 1. You never write it. So that would be the correct answer to number 7. Looking at number 8. Again, we want to try to simplify this root of 72. So I'm going to keep negative 6 plus try that again. Negative 6 plus, and when I square root 72, 9 is the perfect square. No, it's not. Actually, what goes into that is going to be 36. So it'll be root 36 times 2, and that'll be over 18. And then I will simplify this. So negative 6 plus 6 root 2 over 18. And then I will look and see if I can divide something into all the parts, and it's actually 6 that goes in. So if I divide that first one by 6, I get negative 1. Divide the second one by 6, I get positive root 2. And divide the denominator by 6, I get 3. And this would be the simplified answer. Go ahead and pause the video and do number 9. Alright, there's the answer. As you can see, I took the square root of 63 and I broke it down into the square root of 9 times the square root of 7. Simplified, and when I simplified, 3 ended up going into all 3 of the parts. So the final answer was 3 plus 1 root 7 over 7. Alright, so that was review. This is the new learning for today. And again, we're relying on some things that we learned in the past. A square root is simplified when the radicand does not contain a fraction and no radical appears in the denominator. Again, you're not allowed to have a radical in the denominator. And up to now, it's been great because they've all been perfect squares. But starting today, they're not going to be perfect squares. The way that you handle that is you're going to multiply the fraction by an appropriate form of 1. We know that multiplying any number times 1 doesn't change its value. So if we multiply by 1, the value will remain the same. But we have to come up with a strategic one that will allow us to not have a square root in the denominator. Alright, so there's number 10. We have the square root of 1/3. Again, the first thing whenever you have a fraction is you do have to split it into the square root of 1 over the square root of 3. Now, before we were able to have a perfect square down here at the bottom, but this time we don't. So we actually can't simplify this currently as written. But the rule is we're not allowed to have a square root in the denominator. So we need to multiply this fraction by what we call a strategic 1. Now, it's very easy to come up with it. It's going to be whatever is in the denominator if it is a singular term. So I want to multiply this by the square root of 3 over the square root of 3. Alright, so you can see square root of 3 divided by square root of 3 is 1, so I'm not changing the value. And I'm going to go ahead and multiply that. So I'm going to get square root of 3 over square root of 9. And you'll see what happened here is that square root of 9 is now a perfect square. Now I can simplify it. So I'm going to get square root of 3 over 3, and that is the answer. Now I can't simplify this because the 3 in the numerator is in the radical and the 3 in the denominator is not in the radical, and they're not considered like terms, so you actually can't simplify that any further. So that is the correct answer. Alright, number 11. Again, start the same way. First thing I know is I can't have a fraction in a square root, so I have to split it. So it'd be square root of 11 over square root of 5. And now what I have to do is I have to multiply this by a strategic 1 since I can't simplify the square root of 5. Again, very easy. You're going to multiply it by whatever the denominator is. So root 5 over root 5. And again, that is worth 1. So I'm not changing the value. And then I go ahead and I multiply, and I get negative root of 55 over, it's not negative, excuse me, the root of 55 over the root of 25. And when I simplify that, I end up getting negative root of 55. Again, it's positive root of 55. I keep saying that. I don't know why. And the square root of 25 is 5. Again, I know 5 goes into 55, but because 1 is in a square root symbol and 1 is not, they're not like terms. You cannot divide them into each other. So this is going to be the correct answer. All right, why don't you pause the video and try number 12. All right, hopefully you multiplied it by root 2 over root 2, and you ended up with root 54 over 2. Now, what hopefully you saw, but you might not have, is actually the numerator here, root of 54, actually can be simplified. And anytime you finish a problem and it can be simplified, you will need to do that. So 54 is the same thing as root of 9 times root of 6 over 2. And then the correct actual simplified answer is 3 root 6 over 2. All right, go ahead and try 13. All right, and there is the answer. Hopefully you multiplied it by root of 7 over root of 7. Again, that's your strategic one in this problem. And you're going to get the root of 224 over the root of 49. And of course, now 49 is a perfect square. And then at the end, though, 224 is not simplified, and it can split into root of 16 times the root of 14, and your final answer is 4 root 14 over 7. All right, last problem we're going to do today is a fraction problem, and again, it's just adding an extra step to it. First thing is it's a fraction, so we have to treat it like a fraction before we even deal with anything else. And in fractions, of course, when we're adding, you have to have a common denominator. So I look at this one, I have to decide, does it have a common denominator? And the answer is yes. If it doesn't, then we would have to do more work to get a common denominator, but that's not going to be in the lesson today. So because they have a common denominator, I'm going to add the numerators based off the rule, which is 7. And you keep the denominator the same, which is root 7. But now this one is not simplified because you're not allowed to have a square root in your denominator. So what I need to do is I need to rewrite this and again multiply it by my strategic 1. And my strategic 1, of course, this time is going to be root of 7 over root of 7. And that'll give me 7 root 7 over root of 49. And then I will simplify. So the top is good. As I was saying, 7 root 7 over 7. But then it can be simplified because I have a common factor in the top and the bottom, so I can divide them both by 7, and I end up getting 1 root 7 over 1, but you wouldn't write that, and that is the correct answer. Thanks for bearing with me today. This is some growing pains. I have not done this, and that was my first time, so hopefully it wasn't too bad for you, and you're able to follow along. And I'll have one for you again for tomorrow. All right, have a great day, everybody, and hopefully that we see you soon and your family stays safe.